Hi, I'm Dr. Holly Lopez, and this is Meaningful Math for Young Children. A little bit about me. I've been in the field of child development as a teacher, director, administrator, and consultant for 20 years, and I am passionate about advocating for all children to have quality early education for later academic and lifelong success. The purpose of this training, which is a little bit shortened, is to begin to address the stigma of math and also inspire parents and early childhood professionals to become early math advocates. Let's start this training by thinking about math in our daily lives. This is a great resource you can share with families or other professionals that I like to use as an icebreaker in my early math trainings. For instance, I'll have participants find different individuals from around the room who are good at each of these activities and get them to sign this handout. And when they have a signature in each box, they can shout, bingo, and win a prize. So take a minute just to read the chart. Do you or can you do any of those things? Can you knit? Are you good at judging distances when driving? Can you make quilts? Can you choose the line at the grocery store that will take the least time to get through? I'm terrible at that one, number 3. How do these bingo items relate to math? Right? They require sorting. They require thinking about patterns. They require judging distance and measuring, even with non-standard measurement, right? My mother's a master quilter. Does she think of herself as a mathematician? Well, she should. Math is everywhere. We do not give ourselves enough credit for the math we do in our daily lives. This bingo game highlights the importance of math that we use every day, and children also use and learn math in their daily lives. Parents and teachers can support this kind of everyday learning and easily turn it into math learning. We are already math experts. Additionally, I'd like to say before we go any further, let's recognize and appreciate that math is for everyone. All children, regardless of their unique abilities, can learn math concepts. This includes children with disabilities. Let's keep the strengths and needs of our children and their families or your families in mind as we move through the content and activities in today's webinar. But why? Why is it important for us to support young children's early math learning? So the Early Childhood Longitudinal Study kindergarten cohort identified over 20,000 children at kindergarten entry and followed over half of them into elementary school. What they found was that children living in poverty were on average behind in their math knowledge at kindergarten entry compared to children from more economically advantaged families. Significantly, the children's math knowledge at kindergarten predicted their success in 5th grade and in 8th grade reading and math achievement. And note that both reading and math achievement were more successful when children had math knowledge at the school readiness level of kindergarten. So bottom line, early math is critical. Children who are prepared have an advantage that carries far beyond the early years. Families and early childhood professionals have the unique opportunity and responsibility to provide and support math experiences for children and families to narrow this achievement gap. So what am I saying exactly when I say we need to support early math experiences? Early math is broad and it's deep. It is so much more than learning to count and learning the names of shapes. And here's where folks get intimidated. These sound like fancy words, and many people get intimidated by them, but remember, we do these things every day. We work with operations, we are using our spatial sense, measuring, we're working with patterns. So let's talk more specifically about the nature of early math in children birth to 5. So young children develop concrete ideas about such things as number and shape through everyday activities and objects. However, math concepts and skills, such as learning the number sequence, 1, 2, 3, 4, 5, can't just be discovered, but it needs to be learned from adults. Children's self-guided discoveries are important, as we know, in the early years, but guidance and support from adults in math is particularly essential. Early math knowledge is based on children's concrete experiences and ideas, not abstract symbols learned in schools. So while the earliest math learning may not look like the math we remember learning in school, it is foundational to later school math. This is one slide specifically for teachers. Have you ever noticed that most early childhood classrooms don't have a math section? There's a writing area, there are manipulative blocks, art section. Math doesn't often have its own area because math is everywhere. But this is also why math learning can be easy to miss in an early childhood setting. Math is sneaky. It is intertwined in all these areas. This is a great image that can inspire us to see the math that we are already doing in the many areas of our classrooms and our daily lives, so that we also ensure we don't lose the math we are already incorporating. So what experience do we have exactly about the best ways to support math learning? Research shows that children need hands-on or concrete experiences where they are first associating items with numbers. They need to be introduced to math skills in a developmentally appropriate way, and we'll talk a little bit more about what that means later in this training. And this is one of the things we're going to focus on in the bulk of this training, children need to hear math-related language, and we're going to call this math talk. So what is math talk exactly? Math talk is using words about number, quantity, shape, space, and dimensions. These first two bullet points are fairly easy for us as adults and teachers to remember when working with children, but don't stop there. There's so much more language that children need. Pointy, wide, under, up, forward, backward, taller, heavier, shortest. Hopefully you can see in this slide how much math talk is actually happening in our daily lives. And that math talk can happen anywhere, anytime, when adults and children's conversations involve math concepts and vocabulary. So what I'd like to do next is actually have you watch math talk in action, as well as a few experts talk about their own experiences using math talk. Want to help me count? 1, 2, 3, 4, 5. Research has shown that number sense is very critical in preschool, and children are actually developmentally tuned in to learn number sense in preschool. The more you talk about numbers to children, the more they learn numbers. How long do you want this to take? 40 hours. 40 hours? Or 40 pieces? 40 pieces. Okay, how many pieces do you have there? 1. I find myself trying to use math talk in every center that I'm in, even at the snack table. How much more juice do you need? A lot more? To make it equal with the water? Let's see. How many children are in the block area? Is there space for you? So just casually using it throughout the day. Snack. And then that's 3 things. She said snack, then block, and then if teachers use rich language about math, or if they encourage children to kind of talk to themselves or to others about mathematics, they'll learn more concepts. How big do you think this house needs to be? Bigger than a what? Okay. I try to engage children using math talk casually. So just modeling the language and the use of numbers. How many cuts do you need? Is it bigger? Is it smaller? How will you know if he fits in there? He fits in there like this. Okay. Do this. I just pick him in the hole. All right. So he said, let's try.
you need to make the house a little bigger? Yeah.
When teachers either ask questions of children that encourage them to talk about their mathematical thinking or how they solve mathematical problems, that they also promote mathematical competence.
Math communication is it's not actually part of the curriculum in many other cultures. There's a lot of doing math. There's not as much talk in math. We found communication was significantly important for children.
Marcus, how much did you think you need? How long do you want your teaching to be? You tell me how long. You tell me when to stop.
Teaching children in discussions and activities around number, whether it be counting or judging amounts or how many spaces to move in a game, those kinds of interactions are very useful for promoting math learning.
What number do I need to get to the pig? 1. You think 1? Okay, let's see. No. What did I get? 1, 2. 2. Ready? Count with me. 1, 2. I did it to the pigeon.
The teachers to encourage children to talk about, say, a wrong answer, to talk about a misconception, to talk about a failed reasoning. Those are all very, very valid.
1, 2, 3, 4. I'm like, you wanted to count when you had 6. Okay. 1, 2. You really can see how you can incorporate it everywhere. It becomes part of your classroom lingo and part of your classroom language.
So in case you're not convinced that math talk is key for young children's learning, here's a brief summary of findings from 3 observational studies of math talk. I would like to point out one of the most important factors, which is down at the bottom here, which is that all the studies included children and families from different socioeconomic backgrounds, so both lower and higher SES. But the relationship between the amount of math talk and children's math knowledge held regardless of SES background. And to put that in a plainer way, no matter the income of the family, high income or low income, more math talk always meant more math learning. So here are a few examples of math talk from these studies. This is just a small sample of what they recorded, but it gives you an idea of what these researchers were looking for. Please feel free to come back to this slide for more math talk ideas. It's worth noting that in preschool studies, some of the math talk took place during planned math activities, but much of it was just incidental to whatever was happening in the child's situation. Additionally, I would like to mention, as we are learning to use math talk with children, it is tempting to ask questions that only require one-word answers. How many cars are there? 2. What is the shape? Square. And I'd like to caution you about this habit and ask you to push yourself further. It is okay to ask these questions, but I want to encourage you to add another question, which is, how do you know? Why do we want to ask that? Because children and math often produce a one-word answer. How many ducks are there? 5. And this doesn't lead to conversation where there is dialogue using math talk. But when you ask an open-ended question, how do you know, the child has a much broader opportunity to engage in conversation. So what kind of math vocabulary should we be using in math talk? This is a wonderful resource that can be found at the California Head Start website. The resource is called Early Math, Ideas You Can Count On. You will find math talk, questions to ask, activities that support each of these domains. And additionally, at this website, you will find resources for parents in multiple languages and professional development tools for educators. We're not going to spend too much time on the next couple of slides, but I want you to see that math talk can be specific to each domain or each of the fancy words that I mentioned earlier in this training. How wonderful would it be to print these out and make signs for the block area or the dramatic play area? What if you made a quick handout for parents to take home so they can find the math at home while they're making dinner or doing the laundry? Math really is everywhere. Another resource is questions to ask. For teachers who are using the class assessment tool, which is becoming very well known in the early childhood world, this is another great resource. You know that child-teacher interactions and open-ended questions are critical to scoring well on the class assessment. And how easy would it be to print these out as reminders as we're interacting with children? What a great tool this would be for a student teacher who's just learning how to interact with children, or even veteran teachers as a refresher. Again, these free printable resources and even more can be found at this website. You do not need to be a Head Start parent or teacher to use these great resources. I'm going to go past the next few slides so we can talk a little bit more in depth about mathematizing your environment. I just want to make sure you have access to this information. And again, you can find these resources and much more at the website I shared with you. I would like to point out one additional wonderful resource, the Erickson Early Math Collaborative, which is one of my favorite resources for planning lessons for specific math areas. For instance, using Math Talk with books, and there are also video demonstrations of adult-child interactions in working on specific math ideas and outcomes. And this website can be found at earlymath.erickson.edu. Now let's explore the idea that math is everywhere with some of these children. Or with some photographs of children engaged in typical experiences. So imagine that you're at the park with your child, or you are monitoring children on the preschool playground. What might you say to this child as they are interacting with their environment, right? Look how fast the balls roll down the slide. Which do you think will slide faster, a ball or a boy? I wonder which ball rolls slow on the grass and fast on the slide. What do you think? Why do you think that's happening? And here, what is the baby doing? What math is happening here? How might you support or use Math Talk to support math concepts? Is the yellow ducky inside the big ducky? Is the other small ducky next to the big ducky? Number and operations. So let's talk about number and operations. What does this really refer to? A lot. Young children's number knowledge includes counting, which is much more than learning to count words, comparing the numbers of objects in two groups, adding to and taking away objects, representing number using words, objects, or written numbers, solving everyday problems with numbers. For example, determining how many children can ride tricycles now and how many will have to wait. Over the next few slides, I'm going to discuss what each of these looks like, and I like to call them fancy words again, but also to remind you how easy it is to incorporate these critical ideas into your interactions with children. So learning about quantity and amount begins very early in life. Infants and toddlers notice number and amount in their environment. Sometimes it interests them very much. We see infant sensitivity to and interest in quantity in their early activities with objects. And when they play, they're exploring and learning about numbers. older infants begin to organize objects into groups and change the amounts by adding or removing objects. They create equal groups by putting things together in a one-to-one correspondence. For example, one doll in each of Daddy's slippers. As they explore and play, they are beginning to develop simple concepts about number. By the time they're toddlers, they understand in a general way that adding objects to a group makes more and taking away objects decreases the number. They know this even when they cannot see the result of adding or taking away. So why is math talk important? Let me take a minute to help you understand the process young children experience in learning about numbers and math concepts. This diagram illustrates the three basic ways of understanding or representing a number. As a group of real things or concrete objects, illustrated at the top of the triangle, as spoken number words, bottom right, and as written numbers or numerals, bottom left. During early childhood, children learn these ways of representing number and link them together to build their number concepts. Children's earliest experiences and understanding of numbers are with objects they can see or touch. So that's up there with the concrete objects. As children learn number words, they learn that the words represent quantities and objects, and they begin to connect this idea of concrete objects to a spoken word, right? For example, a child might ask for 2 crackers and hold out 2 hands to take them. And then later, children learn to read some written numerals and say what the numeral is, label the numeral 3, and you get the word 3, T-H-R-E-E. They connect the word to a symbol, but in the early stages, they don't necessarily understand what the numeral means. Toward the end of preschool, children begin to make this last connection. They learn that written numerals stand for specific quantities of things. And it takes time and lots of experience with numbers to make this last connection. But it is critical to children's success in learning math in school and their school readiness for kindergarten. One way I love to mathematize children's environments is with books. With book reading, children can have mathematical experiences during a familiar and engaging activity. As children and adults talk about the math concepts and relationships they find in the story or illustrations, children build their conceptual understanding and their math-related vocabulary. Problems found in books can stimulate children's mathematical thinking. I'd like to encourage everyone to be intentional in the books you are buying or getting from the library. Finding the math in books is another great resource that highlights books you can get in every domain that we are talking about today. There are specific books that lend themselves easily to math talk, but I'd like to talk about how you can mathematize any book. This is Cats for Sale, which is not an especially mathematical story, but you can mathematize it. So for instance, after reading the story, you can go on to ask a group of children if they can act out the story so that the number of monkeys in the book will match the number of children playing the monkeys. You can enlist them in helping to figure out how to do this. In doing so, you'll be able to assess the children's ability to estimate as well as their understanding and skill in using one-to-one correspondence. There's a great picture in the book of a double spread picture with monkeys in a tree. And you can look at that and talk about how many children are in the class. And you can ask them to estimate, are there more monkeys than children in the class? Are there fewer monkeys or not as many monkeys? Are they about the same? This is a great time also to record children's estimates and their comments. And these recordings are great for portfolios. So depending on the level of the children, either have them count along with you or have them count how many monkeys are in the tree. Ask children if they have any ideas on how to keep track of the monkeys as you are counting them, right? Maybe someone will suggest using Post-its. Some children should be able to explain that since each monkey gets a cap, if you count the caps, you'll know the number of monkeys. Children who have difficulty understanding this point have not yet mastered the principle of one-to-one, that one object means the number one or one unit. And that's a good place to start when you're assessing math skills in young children. So feel free to get creative and mathematize the books that you have at home and in your classroom. I could spend an entire training on finding the math in books, but we must keep going. So young children begin to learn about shapes and spatial relations in their early play with objects interactions with adults. They manipulate and explore objects and learn how shapes of objects affect how they move, how they go together, and what you can do with them. This learning continues as children play with blocks, puzzles, balls, and other shapes. Children need lots of experiences with a wide variety of two-dimensional and three-dimensional shapes, identifying, matching, manipulating, and talking about shapes and their attributes to develop knowledge about shapes. Young children's spatial sense, including ideas about direction and position, by moving their bodies through space when dancing or running or climbing, or by using objects in relation to one another, such as using blocks or working puzzles or creating collages or sculptures. And through these activities, they're learning a language that describes spatial concepts and directionality, position, and order through their interactions with adults. And of course, learning about geometry and spatial sense all starts long before preschool. Infants and toddlers use their whole bodies to explore and learn about shape and spatial relations. They explore the shapes and sizes of objects in their play. When they grasp objects, they put them in their mouths, bang them together, throw them. They put their objects on, in, next to, on top of, right? They move their bodies to reach objects, to go over or around them, and even crawl inside them. Preschoolers continue to explore and learn about shapes and spatial relations in their play, but children are beginning to learn specific content and concepts related to shape and spatial sense. Preschoolers are learning to recognize and name common geometric shapes, but again, we cannot stop there. They should also be able to identify and describe the shapes by their attributes. Attributes are, for instance, how you would define the shape, the number of sides, the number of corners, and form categories of shapes based on their attributes. For example, what is and what isn't triangle. They create and use shapes in constructions, drawing, puzzles, using shapes in a way that are increasingly consistent with their properties or attributes, and in ways that show that they're reasoning about shapes and spatial relations. Gross motor activities such as obstacle courses and creative movement are another great way to inspire math talk. Again, these are all experiences that promote vocabulary around math. It is not simply enough to provide materials to children. Children need adults to give them words and concepts in order to build a foundation for early math learning. So preschool are learning so much more about the world, and they want to know who is taller, who's older, who can run fastest. They want to know who is heavier, who is lighter. They're interested in comparing. They're learning a more systematically appropriate and accurate ways to compare things. So they will be presented with measurement tools like measuring tapes and scales, and I think those are important things to present. But children generally don't fully understand formal measurement. So non-standard measurement is really the best way to start off measuring activities with young children. Here's a quick video that shows exactly what non-standard measurement is and what it can look like in the classroom or even at home.
Ooh. Sure, you know, it's actually okay to use something besides a ruler to measure. You mean we could use a shoe to measure the classroom? Absolutely. And when you use something besides a ruler, it's called non-standard measurement. Yes, non-standard measurement. Very good, Gerald. I think my work here is done. So, Susie, is it okay to measure the classroom with 5 shoes, 7 flowers, and a bunch of Geralds? Well, there are some rules when you use non-standard measurement. You can only measure with one kind of item at a time. Oh, so you could measure with shoes, or flowers, or Geralds. You got it. As long as they're the same size. Oh, just like all the inches are the same size on a ruler. Exactly, Gabriella. And there's one more rule. You can't leave any spaces between whatever you're using to measure, just like these blocks. Oh. Hey, I can be just like those wooden blocks. See, measure with me, okay? I'll be, okay. Okay, let's do it. Yay. You're a scientist. You can try this too. Okay, let's measure the classroom using non-standard measurements. That means instead of a ruler, we'll use something else. In this case, we can use our body. Lie down on the ground and we'll mark your spot with a block so you know where to lie down again. This way, we won't leave any spaces. Now go for it and measure the whole classroom. Keep lying down and marking your spot until you reach the other side of the room. You're almost there. Keep measuring. Hey, it looks like there's room for another half a body. Let's count our bodies and measure the room. 1, 2, 3, 4, and a half. You can also make your own paper body ruler. Just lie down and have your friend trace your body on paper. Then an adult can cut out the shape and you're ready to measure the classroom. Just like before, make sure you don't leave any spaces. Okay, that's 1 paper body ruler, 2 paper body rulers, 3 paper body rulers, 4 paper body rulers, and there's room for 1 more half a paper body ruler.
So I love this episode of Sid the Science Kid, which shows children participating in non-standard measurement. But imagine you can measure with blocks, with Unifix cubes, with a shoe. This is an activity that costs nothing and can be done anywhere. So adults support preschoolers' learning by providing lots of opportunities to explore measurement, thoughtfully planning experiences that encourage measuring and comparing, and using descriptive measurement language. They need lots of experiences exploring, comparing, and measuring in order to build these measuring concepts. As in all areas of math, preschool children need to be encouraged to use language that describes these concepts. And it's critical that adults are close by to support this kind of language. And of course, let's not forget our infants and toddlers when it comes to measurement. They notice size and other dimensions such as weight, speed, and loudness. For example, an infant might respond with a surprised face to a loud sound, or a toddler might put hands over her ears and say, "Too loud." Infants and toddlers explore and learn about size, weight, capacity in their play and daily routines. And then you'll see older infants begin to understand and use words that refer to size and other dimensions, like big, little, heavy, hot, fast. right? And so we can imagine the math concepts that this little guy is exploring in the picture here. In this slide, I'd like to point out that adults emphasize size attributes in an unconscious way in their speech, and this is something we do naturally. This helps young children notice size and learn the words that describe it. For instance, we see a picture here of an adult reading to a young child, a little girl in a pink hat. So as she's reading the book, she might say, look, here's a teeny tiny mouse, and here's a great big elephant. Right? So you can see how we're exploring size even with our voices. And last but not least, we have patterns. So what are patterns? Why are they important? So patterns are important because they are organizers, they're sense makers. They help children learn and remember language, stories, songs, events, even as they're getting ready for reading and learning about comprehension. Patterns are critical for them to be able to understand. They help children remember and carry out simple routines, and these are the foundations for mathematics like algebra and probability. Let's talk about two common patterns, repeating and growing patterns. Repeating patterns are a sequence that repeats. So for instance, you'll see here this repeating unit, which is red and blue. So the unit itself is red and blue, red and blue, red and blue. So at the end of this repeating pattern, what can we expect after the red block? That's right, a blue block. So it's because it's part of a unit. And then we have growing patterns. This type of growing pattern is common in children's books. It's sometimes called a +1 pattern. So we have 1 blue, 2 red, 3 yellow, and then how many green can we expect, right? 4 green. Right? Another example of this kind of pattern is like a unifix, building a stair-stepping growing pattern, which children love to do with blocks or cubes. So let's spend some time focusing on how children learn about patterns and how patterns help children learn. Infants and toddlers are sensitive to patterns and regularity in their experiences. They notice patterns in their routines and learn to anticipate what comes next. They love repetition. They need repetition. They repeat action sequences over and over again in their play. For example, they put objects in a container. They dump it out. They put them in again. They dump it out. Infants and toddlers notice and respond to patterns in playful interactions such as peekaboo. It's also an important building block for the math children will learn in school. But patterns also have a very immediate importance in young children's lives. They provide regularity and repetition, and this predictable structure helps children learn, remember, and anticipate what's coming next and feel safe and secure in their relationship and their environment. And of course, patterns are everywhere in children's play and children's songs and dance. We just need to be intentional as educators and parents in pointing out these patterns. Pointing out the patterns in music and songs and have them create patterns with their bodies, as we see here with some of these children and their music and movement activities. I'd like to just share really quickly this really short clip of wonderful early childhood professionals in Alaska who remind us of patterns also found in our cultures. Watch this video of Alaska Native Head Start teachers doing a traditional dance, and what patterns do you see in the song and the So thank you so much. I'd like to leave you with that. And just a reminder that professional development research tells us that if we don't plan what we want to do with ideas from a training right away, that we tend to go home with great intentions but never turn our intentions into action. So honor yourself as a learner and the time and energy you put towards today to really think through and complete your action plan. What has you excited? What do you want to do with kids or families? What was the most interesting and engaging thing for you in today's training? I do hope this training has encouraged you to embrace your inner math advocate and show that you already are a math expert. Thank you so much for your time, and please reach out if you have any questions or concerns.